All right, let me just resize this real quick. So it says airline charges the following baggage fees: $25 for the first bag, $35 for the second. Suppose 54% of passengers have no checked luggage, 34% have only one piece of checked luggage, and 12% have two pieces. We suppose a negligible portion of people have more than two bags. The average baggage related revenue per passenger is so, and it's as soon as you see standard deviation here, we're going to be finding the standard deviation of this data. It's much easier to calculate that given the calculator. So we're just going to plug in each of the possible outcomes for these passengers and their respective percentages, and the calculator is going to do most of the work, if not all of the work for us. So the first thing I'm going to do is go to my stat menu and hit edit on my stat list. I'm going to clear out the things that are in there. And the biggest trick or the biggest mistake people make is with these outcomes. So we're gonna disregard the people who have no checked luggage because they don't pay anything. If you want, you can add the case where they pay zero, but it's not necessary. So we'll just ignore that. So every passenger, except for the ones who are not bringing bags, is going to either be paying $25 for checking one bag. If they have two bags, here's where the trick comes in. They're not paying just 35. They're paying 35 for the second and 25 for the first. So the people with two bags are actually paying $60. Okay. So what percentage of the people are paying $25? Well, that's the people who have one checked bag. So that's 34%. So I'm going to plug in 0.34. And the people who have two checked bags is 12% or 0.12. Now, if I go back to the stat menu, I can calculate some statistics off of this data using the one variable statistics command. So I'm going to hit stat, then over to calculate, hit the option 1. My data list is L1. The frequencies or their probabilities, those are interchangeable, is coming from L2. So I'm going to plug L2 into that. So I'm going to hit second and then the 2 button to pull up list 2. And then it's going to calculate everything I need for me. So the first thing I'm going to look at is the average baggage revenue per passenger is this, 34.13. You could have found that by taking 25 times 34% plus, not 35, plus 60 times 12%. And you would have gotten a total of 34.13 on average for each passenger. The standard deviation is where it becomes tricky. So that's where we just rely on the calculator to do it. And that's going to be the 15.3688 or 15.37. How much revenue should the airline expect for a flight of 120 passengers? Well, if you have the answer to the first one, this is the average revenue per passenger. So we would just take that value and multiply it by 120. $4,095.60. Okay. All right, let me resize this one a little bit. So this histogram shows the weights of 47 female and 97 male cats. Okay, so this is the number in each weight category, and then these are the ranges of the weights. So you'll see these go up by half pounds. I guess these are in pounds. Oh, kilograms. That makes more sense. Half a kilogram. So we can safely assume that each of these lines, each of these bars is like a quarter of a kilogram. This is 2.25. This is 2.75. This is 3.25 and 3.75. So how many cats total do we have? We have 97 plus 47. That's 144 cats. Yeah. So then this says approximately what percentage of these cats weigh between 2.5 and 2.75 pounds? Well, that's just this bar right here. So that it looks like it's directly between the 15 and the 25. This is going to be 20. So 20 of the 144 would be 20 divided by 144. That's where I get the 13.88 repeating, or we'll say 13.9%. I don't think they have. Well, they want two decimal places. We'll do 8, 9. What percentage of these cats weigh between 2.75 and 3.5? Well, 2.75 and 3.5, that's going to be this bar, and this bar. So we'll add up these heights. See, this is kind of, you kind of have to eyeball it. This one definitely looks like 15. This one looks like, is that 25, I guess? And see, now this is why this one's tricky. What is the height there? If this is 10, they must accept the range, but that doesn't look like 10 to me. So I would say 12. So I don't know if they would accept the range. That's the only way you could go about doing it. But let's see, 25 plus 12 plus 15, that's 40, 52. 52 out of 144. 36.11%. I believe that they should accept the range of values for this. If not, I'll have to catch that if it's and turns up in a graded assignment, because that's just hard to read.